Welcome to the Math 1 lesson summary video for the task Pet Sitters. This lesson is a develop understanding task which is meant to introduce you to a concept but not necessarily finalize rules or strategies. The purpose of this lesson is to surface ideas, strategies, and representations related to solving systems of equations and inequalities while considering multiple constraints simultaneously. In this task, we're introduced to the Martinez twins, who are looking to earn some extra money over the summer. They decide to start a pet sitting business where they will be housing cats and dogs. There are a few things that they need to consider when they are developing their business plan. And we can see on the screen, these are two of the things that they must consider: the space restrictions that they have, as well as the startup costs. So regarding the space, they have a total of 360 square feet of space available to them. Each cat pen that they have is going to require 6 square feet of space, and each dog run will require 24 square feet of space. Next, we look at the startup costs. They have $1,280 that they earned from their last business venture to invest in this new business. Each of the cat pens is going to cost them $32, and each of the dog runs will cost them $80. So they want to make as much money as they possibly can, and when they're looking at the amount that they look to earn, we see that they have decided that they're going to charge $8 a day for each of the cats and $20 per day for each of the dogs. So what they're trying to figure out is how many of each type of pet should they prepare for. Well, their dad thinks that they should have an equal number of cats and dogs, like 12 and 12. Carlos thinks that they should have more dogs because they can charge more for dogs. They're going to charge $20 per day for each dog versus the $8 per day. Clarita thinks that they should house more cats since they take up less space and require less time, so they can board more. So even though they're going to charge $8 per day for the cats, which is much less than the 20, they can house more because they require less space. So the question is, how many of each type do you think they should prepare for? Whose suggestion do you think is the best? The dad, Clarita, or Carlos? And then what recommendations would you give to Carlos and Clarita? And what argument would you use to convince them that your recommendation is reasonable? So it's not enough to just give an answer here, to just say, well, they should house this many cats or this many dogs, or I agree with the dad versus Carlos or Clarita. We have to be able to justify our answer. Now, keep in mind that the focus of this lesson is not so much on getting the right answer. We're not necessarily looking for exactly how many cats and exactly how many dogs. We're more focused on the various strategies that we can use to get to that answer. So again, the focus of this lesson is on the different strategies that we can use to come up with the different combinations of cats and dogs. And so that's what we're going to do now, is look at some of those different strategies that we can use. So the first strategy that we're going to look at is a visual representation of the space constraint. We know that we have a total available amount of space of 360 square feet. If we look at that on graph paper, this is just one way to represent this visually. We could have laid this out several different ways. This is just one. This one represents the suggestion that the dad made, which was to have an equal number of cats and dogs, 12 of each. We can see that the dimensions of this are 30 feet by 12 feet, which would give us a total combined area of the 360 square feet that they have available. If we take a closer look at this, we can see the relationship between the dog pens, the size of the dog runs, and the cat pens. We can see that the dimensions of each dog run are 4 by 6, which gives us that total combined area of 24 square feet. And each of the cat pens is 2 by 3. So if we put 4 cat pens together, that is equivalent to the size of one dog run. And so that's helpful to us if we're looking at this in terms of a table. So again, to recap that, one dog run, which is 24 square feet, is equal to 4 cat pens, which are each 6 square feet, times the 4 cat pens would give us that total combined area of 24 square feet. Which means that for every 4 cat pens that we add, we have to take away one dog run. So we could replace any of these dog runs with 4 different cat pens. Likewise, we can replace 4 cat pens. If we want to take away 4 cat pens, we can replace that with one dog run. And so if we look at that in a table form, we can see this kind of exchange rate between the cats and the dogs using a table format. So if we started with all cats, we would have 60 cats and no dogs, because we know that if we have a total combined area of 360 square feet and we divide that by the 6 square feet that each of the cat pens requires, that would give us 60 cat pens. If we only had cat pens, we would have no dog runs. So for every 4 that we take away, we can add 1 dog run. Take away 4 more cat pens, add 1 more dog run, and so on. Next, we're going to look at coordinating the space and the cost constraints with the earnings using tables. So the first table is, again, just looking at the space constraint. We have a total of 360 square feet available. Each cat pen requires 6 square feet of space. Each dog run is 24 square feet of space. We can see that, again, if we divide the 360 square feet by 6, we get 60. That means we could have 60 cat pens with no dog runs. If we divide the 360 by the 24 square feet that each dog run requires, that would give us 15 dog runs with no cat pens. If we divide it equally by 12, then we would get 12. So this is Clarita's suggestion, Carlos's suggestion, and Dad's suggestion. This doesn't mean that these are the only 3 possibilities. These are just 3 that we're looking at in this video. The expectation is that you, the student, would try several different options and combinations to see which work. So when we're only looking at this space constraint or space restriction, and we look at the total amount of space used for each of these suggestions, they all require 360 square feet. And so they all meet this space constraint. Next, if we look at the cost constraint, remember they have $1,280 to use as startup costs for this business. If we only have cats, then again, we would have 60 cats. If each cat pen costs $32 and we multiply those together, that would give us a total, or require a total, of $1,920, which we know is too much. They don't have that much to invest. If we look at the dog runs, We know that we would need 15 of those at $80 a piece. That would cost a total of $1,200. So this one would work, this combination. And then if we look at 12 cat pens and 12 dog runs, 12 times the $32 each would cost $384 for the cat pens, and 12 times the $80 per dog run would cost $960, which would give us a total of $1,344. Again, this $1,344 is too much. They don't have that much to invest. So we know that this combination would not work. It would not work due to the startup cost constraint. Next, if we look at the earnings, how much they plan to earn or they would earn with each of these three combinations. Again, I can't stress enough, you should be doing more than just these three. These are just the three basic that were introduced in the task, but they're not the only options, and there may be better options out there other than these three. So when we look at the earnings, if we have only cats, 60 cats at $8 a piece, that would give us an income of $480 for the day. If we only had dogs, 15 times the 20 would give us $300 in earnings for the day. And if we had 12 cats times $8 a piece, that would give us $96 per day in income from the cats, and 12 dogs at $20 per day would give us $240 income for the dogs, which would give us a total income of $330. We can see here that they would earn the most money if they only used cats, if they only housed cats. However, if we look back at the cost constraint, we know that housing only cats is not an option. Housing only dogs, housing an equal amount of cats and dogs, we found due to the cost constraint was also not an option, even though they would earn the second highest amount of money out of these three combinations with this one. So they would earn the least amount, the $300, with the only option that works due to the cost constraint. One of your objectives is to find other combinations where it would meet the cost constraint, meet the space constraint, and earn them more money than this. There are other strategies that you can use as well. Some students may come up with the equations, or they may come up with inequalities to represent this scenario and find the different combinations. Some may use combinations of equations and combinations of inequalities. And so we'll be looking more into this storyline and see what happens with Carlos and Clarita and their pet sitting business in the upcoming task.